Hello friends, so here we will going to discuss the solutions of the class 12 physics board exam question paper. So I have taken the question from the question paper having the set 215543, means that is the fourth series and the set number 3. So we're going to see the solution of those all MCQ questions which were involved in that particular question. I have already uploaded the solution of this question paper of some numerical question, but I have not yet uploaded the MCQ solution. So here we will going to see in detail answer of the all MCQ questions. Means there were the 12 MCQ questions and the 4 were assertion reasoning questions. So we will solve all those questions. Then we will also discuss or explain each and every question in detail, so you will going to get the idea how the answer of any particular question will be there and why not some answer would not be there. Basically I have gone through the references and all. Even though I have seen lots of the websites have just made a false promises and they have uploaded lots of the YouTube channels are telling you the very false and very incorrect answers of the MCQ question. So those queries will also be going to get clarified here. Lots of the people have only given the incorrect answers or partially provided the answers and skipped lots of the question and all. So obviously because of all these things the students would not going to get satisfied, and because of that I thought that I would going to make that particular video which will going to give you a particular insight of any question. And paper was not too much hard, but obviously it was slightly on a conceptual basis, means there was a requirement of the in-depth analysis of particular formula or the concept of any particular theorem and all. So we will going to see and we will start here. Some questions are very easier one. While telling the solution of those particular MCQ, I will going to explain everything and all, and that which question is easier one, which question require what type of the techniques and all. And I will not going to provide only the correct option. I will also going to give you the explanation of that particular answer, so it will be easier for you to go further and all. So we will start here, and one request is that if you are watching this video first time from my side, if you are visiting this channel for the first time, so it's my humble request that you can subscribe this channel and share these videos to other people. So you have to just click on the subscribe button and you have that particular bell icon. Thank you. Now we will going to start this particular section. So you can see the question is given on the screen. That is the first question of the MCQ section. An electric dipole of dipole moment P. What is given? We have given an electric dipole having the dipole moment P is kept in a uniform electric field E, and it is kept in an electric field E. I know that dipole is, what is the dipole? It is a system of two equal and opposite charges which are separated by some particular distance in between them. Now what do we have to calculate? The amount of work done to rotate it from position of a stable. So this, there is one dipole and having the dipole moment P. Now we have to rotate that particular dipole from the stable position or stable equilibrium to the unstable equilibrium, and while that particular rotation we have to calculate the amount of work done that has been done in that particular rotation. So what do we have to calculate here? Basically we have to calculate the work done on that particular dipole while rotating it from the stable position to the unstable equilibrium. So basically for this a given formula is a very easier one, and that is work done by the dipole or on the dipole will be given by dipole moment multiplied by strength of the electric field in bracket cos theta 1 to cos theta 2. This is the basic formula that you should know for this question and all. Now in the stable position, whenever the dipole used to be in the stable equilibrium, then the angle of that particular dipole is used to be 0, means it is a parallel to the electric field and all. And another one is that if the dipole is in unstable equilibrium, means the angle between the dipole moment and that particular, or we can say dipole or dipole moment vector and the electric field is used to be 180 degree, or we can say pi radian. Okay, so we will just put the values here and we will going to get the answer. So I will put here, what is that? 0 is for stable. Yes, I will write here stable, and it is for unstable equilibrium. Okay, so I will put the values here. What? So cos theta 1 is 0 here, minus cos pi. What is pi? 180 degree. I know that cos 0 is 1. Cos 0 is 1. And what is cos pi? Cos pi is minus 1, and it is already minus 1, so it will become plus. So it is, so what will be my answer? That is 2pe. That will be the answer. Okay, so this will be the work done to rotate that particular dipole from stable equilibrium to unstable equilibrium. So my correct answer should be this option number A, that is 2pe. We will go for the next question now. Now this is the another question that is given here. What is given? An infinite long straight wire having a charge density lambda. What is charge density? It is a charge per unit length of any particular conductor. Now it is an infinite straight long conductor, we know that, is kept along a y dash y axis, means it is vertically inverted. So we can say it is kept along a y dash. What is that? It is a vertical axis, that we know, in the xy plane. The Coulomb force on a point q. Now what we have to find out? We have to find out the force, that is a Coulomb force, that is electrostatic force on a point charge q, which is placed at a distance or at a point p x0 from the conductor or wire. So we can say, what is the coordinate that is given here? X0. So from this coordinate we will going to get the idea that point P is lying on the x-axis, So what is this x? This x coordinate will give us the directly perpendicular, or that is just short distance in between that conductor and the point at which the charge q is placed. So for this we have a direct formula basically. So what is that particular direct formula? That is, for long straight current carrying conductor we have a given formula, that is q divided by 4 pi epsilon naught, and that is integral of L dl upon lambda dl upon r square. Okay, and that is, now what is the direction here of the r vector or distance vector? That is direction along the x-axis. So obviously there will be no any confusion. So in place of the r I will write here only x, and after doing the integration I will going to get that particular direct formula. What is that? That should be q upon 4 pi epsilon naught multiplied by, what is there, lambda, yes, and then it should be x. So because of that we will going to get the answer, that is, so how it comes basically, so after doing the integration and all we will going to get this value. You will going to get that particular idea. We don't have to do the integration here because it will going to consume the time and all, and already whatever the answer will be there, that is the direct answer that is given there. So I will just simplify this. After doing the integration I will going to get this particular value 2 lambda upon x. Okay, so don't think about this too much and all. Even though if you are students of the physics or maths, if you are students of math, then it's fine. If you are the students of the biology group, that is PCB group, and also sometime it will be going to get very hectic for you how it comes and all. So you can just roughly solve it. You will going to get this particular value. So here 2 divided by 4, that is 2. So it will become q lambda upon 2 pi epsilon naught x. So now I will going to check this option whether it is given somewhere or not. So you can see here it is option that is given here. So it is a option number A, that is attractive, and that is q lambda upon 2 pi epsilon naught x. Okay, I hope that you got this solution. Even though if you are not understood this solution and all, I will try to put a separate video on this individual question, or the question like this, so that you will going to get the more clarification how it comes and all. So I will trying to do a work on it separately, so it will be easier for you people to understand that particular concept. Now we will move further. Another question that is given. Now this is a very basic and straightforward question which is asked from the chapter which deals with the electromagnetic waves and all. We know that in the electromagnetic waves it consists of the electric field and the magnetic field, which are mutually perpendicular to each other, and again together those two individual fields are also perpendicular to the direction of the propagation of the electromagnetic waves, or we can say EMW. So what do we have to do here? So in this case we have to find out the phase difference between the electric field and the magnetic field. Basically it is a very conceptual and the direct question. So what happens is that any electromagnetic wave is directing along the z-axis. Obviously if it is propagating along the z-axis, so electric field will be on the I, and that is x-axis, and magnetic field will be along the y-axis, and the third axis that is remaining, in which the electromagnetic wave will going to get propagate. Now we have to find out the phase difference basically. So what is the phase difference? So we should know that that is a angular difference in between the propagation of these two individual electric field. Now we know in the electromagnetic waves, for any electromagnetic wave, we have given the instantaneous values of the two field, that is electric field is written by E equal to epsilon E naught, then sine kx minus omega t. We all know. If you don't know, then you must have to refer your textbook and all. You will going to get this relation. Similarly, the magnetic field, instantaneous magnetic field, is written as B naught. What is B naught and E naught? These are the peak values, sine kx minus omega t. Now you can see what is the phase angle. What is the phase angle here? That is same. It means that we can say that there is no any difference in between the phase angle of the electric field and the magnetic field. Means there is no phase difference, no phase difference, or we can say the phase difference is equal to 0. That is the answer that is given in the option first, that is 0. Okay, fine. Now here you may going to get confused that basically all these fields are propagating perpendicular to each other, mean direction of the electric, magnetic and that particular wave are mutually perpendicular to each other. So you will going to choose this answer, but this answer will not be the correct answer. Why? Because this pi by 2 is the direction of the propagation. It gives us only the direction because it is the angle between those particular fields. It does not give us the phase angle. So phase angle means the, or phase difference means what is that? It is angular difference in between the propagation of any particular wave. So from this relation only we will going to get that answer, and that should be 0 only. Now we will going to see the question number 4 that is given here. In the Balmer series of the hydrogen atom, as the wavelength of a spectral line decreases. What is that Balmer series? It is a second series of the hydrogen lines which are emitted. Then in this case we know that the ground level state having always n equal to 2. As now what is asked here, as the wavelength of spectral line decreases, this is the direct sure shot question that is pick up from the basic concept. As the wavelength of spectral lines decreases, so what will happen in the spectral or hydrogen spectra? If in Balmer series n, final n is equal to 2, then other n can be always higher than the 2. So because of that, what will happen, as I will going to increase that particular value of the n, as I will going to increase the particular value of the n, what will happen? What will happen there? There will be the increase in, there will be the decrease in the value of 1 upon lambda. That is a wave number. That is a wave number. Now what is given here? Here we have given the wavelength of a spectral line is decreases. So can I say wavelength is decreasing? So because of that, what will happen? This relation in which we write RH, or we can say RZ also. Okay, so that will be NF final. I always write NF and NI. You can give the subscript, that is 1 and 2. It's fine. Okay, with this relation. Now what is happening here? If the wavelength will going to get decreases, the number of waves will going to get increases. Now in the given particular region, if the number of waves or number of lines are going to get increases, means there will be the crowding, there will be the convergence, means there will be the increase in the number. So because of that, they will be coming close to each other, and their intensity will become less, so they will weak in their intensities. So our answer will be this. Okay, so this is a simple explanation for that particular question. Okay, I can give you a small proof for this particular question. You may find the simple reference for this question here, in which it is written in 1885 the first series was observed by the Swedish school teacher Jan Jacob Balmer in the visible region of the hydrogen spectrum. This series is called as the Balmer series. In the Balmer series, what happens when the wavelength decreases, the line appears close together because the line numbers will going to get increases, that we have seen from this particular relation, and they get weaker in the intensity because now the same amount of the intensity will going to get distributed into the large number of the line or large number of the spectral line, and because of that they will going to get weak in their intensities. So, and reason of this is also given because as the energy level increases, the gap between the successive energy level decreases, and because of that they will going to converge towards each other, all or the spectral lines will come together and they will be weaker in their intensities. We'll go for the next question now. This is one good question that is given in the question paper. Basically, this is the question which require a little bit logic and all. Obviously, we are going to use some basic concept here. Again, the same formulas and all. So let's see how to solve this question. Two long straight parallel conductors A and B are kept at a distance r carry. Now there are two conductors, okay, which are kept at some distance r from them. So r, I can say it is a conductor, it is a conductor B. Now a third identical conductor, means same conductor, is there. Now the current flowing through these two conductors is I, and this is also I, but in opposite direction. And you must know, whenever there are the two parallel conductors which are kept together at some distance and the current flowing through them is in the opposite direction, then they will going to repel to each other. Okay, now a third identical conductor C is kept at a distance from A. Now from A there is one identical conductor that is kept at a distance r by 3 from A, r by 3 from A. So this is the conductor C, and now the current is flowing from C in the same direction as that of A. So what will be there? There will be the attraction in between them. Now the net magnetic force on the now the net magnetic force on unit length of C. Now what we have to calculate? We have to calculate the net magnetic force which is acting on this particular conductor C. So what we have to calculate here? We have to calculate the force per unit length on the conductor C. So I can write in such a way. So we have to calculate now. Basically we know that force acted by any conductor on the another conductor which is kept at some distance will be calculated by using a basic formula that we all know, that is F upon L equal to mu naught I1 I2 upon 2 pi r. What is r here? R is the distance between the two conductors. Now in this case I will take two cases. I will going to take the two cases. What are those? Basically I will say that the force per unit length of a conductor C due to the conductor A can be, according to this formula, what will be that? That is mu naught. What is the current that is flowing through the conductor A? That is I. What is the current that is flowing through the conductor C? That is I1. Yes, I1, and it is r by 3. What is the total distance in between them? That is r by 3 to 2 pi. In place of capital R, or in place of the distance, I will write r by 3. R by 3. So it will become 3 by 2 mu naught I1 I upon pi. Clear? Now this is the force per unit length on the conductor C due to the conductor A. Now similarly we have to calculate the force, magnetic force on conductor C due to the conductor B. So we will see. Now this is due to A, we should know. Now force on conductor C due to B. Now again mu naught. What is the current that is flowing through the B? That is again I. This is I1, 2 pi. Now the distance will be changed. Earlier the distance was r by 3, total distance is r, so remaining distance will become 2r by 3. You should know how. R minus r by 3, that is equal to 2r by 3. So total distance here will be 2r by 3. There is no square. Okay, don't write mistakenly the square of that particular distance, otherwise it will be wrong. Now 3 will be on the numerator side, mu naught I1 again divided by, now 2 will become 4. So I will write 4 pi r. 4 pi r, correct. Okay, now this is the 2. What we have to calculate? We have to calculate the net force. Now from the equations 1 and 2 we know that the force due to the conductor A is more. Why? Because it is very near to the conductor C. So net force per unit length for C will be equation 1 minus equation 2. Equation 1 minus equation 2. So I will write here this minus this. Okay, so I will do the subtraction of this. So first I will write the equation 1 value. So that is 3 by 2 mu naught I1 I2 divided by pi. Okay, I forgot to write here r. So r minus 3 mu naught. Why minus? Because we have to calculate the net na, bigger force minus lesser force, so whatever the remaining force will be there, that will be the answer. Now by taking the LCM, what is the LCM here? 4 pi r. My answer will be 6 mu naught I1i minus 3 mu I1i. Okay, so it will become 3 mu I1i upon 4 pi r. That should be the answer. Now most of the students may have done it wrongly, that they have forgot to do the minus and all. They have written this answer. This answer is the only correct answer of this particular MCQ question. So let's see where is the option given. So here the option number C will be correct answer, and secondly it will be towards A. It will be towards A. Why? Because the force due to the current conductor A or wire A on the conductor C is more, so it will be towards A. And I have already told you that in the initial section or initial part while starting the solution or explanation of this particular question, that whenever the current are flowing in the same direction, then there will be the attraction. So it will go towards the conductor A, and the answer will be option C. Here we will going to see the next question, that is question number 6. This is the one question that is related with the electromagnetic induction. Now initially I am going to telling you that mostly these question have very contradictions which are linked with this question, because what is happening here is that whenever I have tried to solve it on the rough and all, even though I did not got a satisfactory answer, so sometimes I think that the options are not correct, and some other people have given a very wrong answer, means they have not given the explanation of this particular question, they have not tried to even solve it. Some people have given a random answer that option C or option A or option B will be correct and all, but we will try to solve this question, we will try to obtain the answer. So what should be the correct answer of this question, that will be identified here. So we will try to solve it. If we will get a particular answer, then that is fine, otherwise we will keep it for the CBSE itself. Fine. So let's see. Now a coil of n turns is placed in a magnetic field. A coil having the n number of turns, and it is placed in the magnetic field having the strength. Okay, so magnetic field is perpendicular to the plane of coil. B changes with time. Now the instantaneous magnetic field that is given here, that is B naught cos 2 pi by t into t, is given where t is a time period, so we know that magnitude of EMF is induced should be calculated. So what we have to calculate it? We have to calculate the magnitude of EMF or the voltage that is induced, and that should be maximum one. So when the maximum magnitude of the EMF will be induced, that we have to calculate. So we have to calculate the time t. So first, what is that small t? Small t is the time. Okay, so we have to find out the relation of the small t with respect to that n and t. What is the n here in the options? That is the integral value 1 2 3 4 5. That's all. Okay, leave it, that is another part and all. So we're going to solve this question, how we will going to approach for the solution and all. So basically this relation is given to us. What is that? It is the instantaneous value of the magnetic field, that is B equal to B naught cos 2 pi by t. Now we know that the EMF induced in any particular, what we say, in particular magnet, so we know that the EMF induced in any material or conductor or a wire due to the magnetic field or changing magnetic field is given by NBA omega sin omega t, NBA omega sin omega t. Now what is omega? I don't know, but I can take the help of this particular relation that is given here. So can we say B equal to B naught cos 2 pi by t multiplied by t? So in this case this is the omega, that is the omega. So I will write here omega equal to 2 pi by t, basically 2 pi by t. So I will going to put that particular value here, so I will going to get the answer itself. So I will write here NBA multiplied by omega. In place of omega I will write 2 pi by t what is given here then? Sine omega means 2 pi by t into t, that will be the relation. Now I can simplify this, it will become 2 nba pi upon t sine 2 pi by t into t. Now we have to check the maximum value of the EMF. Now we know that the value of sine vary in between -1 to 1. So if I have to calculate the maximum EMF, then for maximum EMF I will require the value of sine, whatever the sine that is given here, sine 2 pi by t into t, should have the value that is 1. Yes or no? Should have the value that is 1. So I will say 2 pi by t to t equal to 1. That should be the relation. Now we will go further. Now when we get the value of sine theta or sine omega t equal to 1, when this particular angle will having the value in terms of the pi by 2, in terms of the pi by 2. So I can imply that that 2 pi by t multiplied by t should have the value that is pi by 2, means 90 degree. At the 90 degree, yes, I am not saying that only at the 90 degree we will having the value of sine theta as a 1. In the other angles also we will going to get the value that is 1. Okay, so we know that that is a basic relation of that particular is 2n plus 1 pi by 2 is the one relation, or 4n plus 1 upon pi multiplied by pi by 2 is one relation, in which we will going to get the values of the sine theta as a 1. Okay, leave it. Now here pi will get cancelled, so for t I should get the answer that is t upon 4. Yes, you can see t upon 4. Now what is happening here, there is one integral value that is given here in the option. Now we will check for the option. So what we have got, we have got t upon 4, but basically this option is not given anywhere. This option is not given anywhere. Now we have to apply the integral values 1 2 3 4. So because of not getting the same answer that is given in the options, we can't directly add the n and all. So if we're going to add the n here, then this will, so if n are 1 2 3 4 5, so t by 4, there is one option that is given t by 4, but it is multiplied with the n. So why it is multiplied with the n, I am not getting that particular answer correctly, but I can say that there may be some relation that is given there. So according to me this answer should be correct, or otherwise the another option is this. These two answers should be correct here. Lots of the people have a lot of the confusion regarding this question and all. I am also searching for that particular correct answer, but according to the trigonometric functions and all, we should get the value of sine theta as a maximum in the odd multiple of the pi by 2 and all. But even though that odd multiple 2n minus 1 is also not given here, 4n plus 1 is also not given here, so we got the value only t by 4. So I am saying that this option should be correct here, or otherwise this one option should be correct. Okay, so if you people have tick any one of the options, so be affirmative or positive, otherwise leave it for the CBSE. Okay, we will see later on what should be the answer of that particular question. And because of that, initially I was telling you that there may be some error in the question, or there may be some error in the options of the given question and all. Okay, we will move for the next question now. This is the another question that is given here. Again, it is related with that particular electromagnetic induction and all. So what is given in the question, basically this question is also related with the basic concept, but it is somewhat trickier one, because whatever the options are given here, so only after identifying the options we will not going to get the answer. We have to do some rough, and after that we will going to get the answer here. So a circular loop of radius r carries a current I. There is one circular loop A having the radius r and current flowing through it is I. Another circular loop B having the radius r by 4, another circular loop B having the radius r by 20, okay, is placed concentrically in the plane of A. In a plane of A means there may be some structure like this, in which, now you can see from this the radius of the A is bigger one, so this should be A, and radius of the another B is smaller one, that is r by 2, so we'll take it as an inner circle or circular loop. Fine. Now the magnetic flux linked with the loop B is proportional to. So what we have to find out? We have to find out the magnetic flux in terms of the radius, and we have to check whether it is proportional to the r, whether it is proportional to the r square, or whether it is proportional to the r 3 by 2, or whether it is proportional to the root r. So after solving that particular question, we will going to get the answer of that MCQ question. So we'll see how we can solve that question easily here. Now what we have to calculate here, we have to find out the magnetic flux linked with the loop B, and that flux will be generated due to magnetic field of the loop A. So for that we have a simple formula that is phi B is equal to BA, that is magnetic field A, and area of the loop B, because we are finding the magnetic flux linked with the loop B only. Now what is the value of the magnetic field that is induced or that is related with the loop A? That should be mu naught IA upon 2r. Mu naught I upon 2r. What is that r? R is a radius. So by using this relation we will put the values here. So it will become mu IA upon 2r multiplied by area of loop B. What is the area of a circle or circular loop? That should be pi r square. Now I will write here pi r square. Basically it will be mu naught IA upon 2r multiplied by pi. What is the radius of the second loop? That is RB here, that is r by 20. So I will write here square. You can see from this relation whatever the answer will be there, so it will be mu I a pi, and that is r square upon 2r multiplied by 400. 2r multiplied by 400. So the answer will be magnetic flux linked with the coil B equal to mu naught IA r square multiplied by pi 800 multiplied by r. Okay, there is r square here in the denominator, it is only r. So what is remaining here now? Mu naught I pi upon 800 multiplied by r only. 1 r will be remaining here. Yes or no? Yes. So what is happening? All these quantities, whole this quantity is constant. So can I say magnetic flux is proportional to r? Magnetic flux is proportional to r. So I can say magnetic flux linked with the coil B is proportional to the r. So my answer should be first option, that is r. Fine. I hope that you got the solution. We will go for the next question now. This is the one question which is directly given on the formula basis. So in this question, a galvanometer of resistance 100 ohm. So directly write resistance of the galvanometer, that is 100 ohm. Basically we give it as a capital G. Okay, symbol. Now is converted into the ammeter of a range, ammeter having the range, current range, that is 0 to 1 ampere. Now whenever we use the galvanometer as ammeter, we always connect a shunt resistance, small shunt resistance, in a parallel to the galvanometer resistance. So it will be 0.1 ohm, that is given in the question itself. The ammeter will show full scale deflection. Now ammeter is showing the full scale deflection, so the current value shown by the ammeter will be maximum, that is 1 ampere. So that is the current that is flowing through the whole circuit after connecting that shunt. For a current about means what we have to find out? We have to find out the current, that is Ig. Sir, how to identify the Ig? That has to be calculated, or I has to be calculated. You can see here ammeter is showing the full scale deflection, means ammeter is showing the full value of current, means that should be the maximum value of the given range. Yes or no? So because of that, so now what do we have to calculate? We have to calculate the current that is flowing through the galvanometer. Fine. So you can see here so we know that we used to be given one direct relation between the particular galvanometer resistance and the that shunt resistance. in case of the ammeter conversion. Or even though if you don't know that particular formula, you can directly apply the concept that when we connect the two resistors in the parallel to each other, then the potential difference across them used to be equal. So if I say the Ig is the current that is flowing through the galvanometer and G is the resistance of the galvanometer, then this will become the potential difference across the galvanometer, and that potential difference will be equal to I minus Ig, that is the current flowing through the shunt, and value of shunt. So from this relation I will going to get one idea that Ig equal to Si minus Ig. So by doing the arrangement I will going to get the value of Ig equal to Si upon G plus S. Now what is the value of S here? We know that is 0.1 ohm. 0.1 ohm, that is given here. What is the value of current I? That is 1 ampere. G, what is G? 100 plus 0.1. So basically it will become 0.1 divided by 100.1. So it will become 1 upon 1001. So after doing the division of these, you will going to get the answer, that is 99999. Okay, so on. So it will be in ampere. So can I write this value as Ig equal to 0.000, that is 99 is there, so I can just convert it. It will become 1 ampere. Now that can also be written as, I will transfer the decimal point on the right hand side, so it will become 1 into 10 to the power minus 3 ampere, or 1 milliampere. So we'll check whether the given option is there or not. So you can see the option number B is there, that is 1 milliampere. So this should be your answer of this question. I hope that you got the concept of behind this question. What we have done, we have just applied the condition, that is Ig equal to Si upon G plus S, and we got the answer here. This is another one question which is trickier one, you may say that. So what is given here, we have to calculate the RMS value. So what is given here, we have to calculate the RMS value of a current which is given, okay, so which is given by the instantaneous value, that is I equal to I1 cos omega t plus I2 sin omega t. Now what is happening here, the current is given in a such format that we called as a vector format, and all means we have given the current in the two direction. Obviously it is a instantaneous current. Now we have to find out the RMS value. We have to find out the RMS value of that particular current. Basically RMS value is given by that particular I, complete amplitude of the current, and then divided by √2. So for that, first I will require the resultant current, or we can say that is the equivalent current or the peak current. Okay, so first of all we are going to obtain that current here. Now basically we know that for the instantaneous value of the AC current, that we usually write I equal to cos omega t, I equal to I naught cos omega t, or I equal to I naught sin omega t, and that. But here we have given the two components of the given current, so first we have to simplify it. Now for cos omega t I can write that, you should know, or you might know, that I1 cos omega t can be again written as a sin omega t plus pi by 2, basically pi by 2, plus I2 into sin omega t. What is happening here, now the equation got all the values in the sin. Now in this component, that pi by 2, what is pi by 2? It is a extra, that is a phase angle phi in between the two components I1 and I2. Two components I1 and I2. Two components. So what is this pi by 2? Pi by 2 is the phase angle in between the I1 and I2. So basically now if I have to find out the resultant value of this, as we do in the vectors, what we do when we have to calculate the resultant of any two simple vectors or the component, that is A and B, then we write A square B square plus AB cos theta. Now here theta is our phi, and what is the value of phi here? That is pi by 2. So for this case I will write the total resultant value, that is I naught, or we can say peak value, is given as A is amplitude of the first current, that is I1 square plus that is I2 square plus I1 I2 and cos theta. Now in place of the theta or phi we are taking here the pi by 2. We are taking here the pi by 2. Now we know that cos pi by 2 is 0. So this whole term will become 0. So what is remaining here? I equal to under root I1 square plus I2 square, because this whole term will become 0. Now this is the value of I. So how can I calculate the RMS? From this relation I will put the value of I here. So what will it become? It will become I RMS equal to under root I1 square plus I2 square divided by under root 2. That is the option which is given in the C option. That is the answer that we have to pick up as a correct answer of this question. Here we have to see the one question that is given which is based on the photoelectric effect. This question is very easier one, but we can say very logical one. Means we will going to make some proper conceptual clarity here, and then we will going to get the answer, because whenever you will going to read the all options you will say that yes, all options are correct, and you will going to get confused and all, because it is a photoelectric effect, totally theoretical and conceptual one, what to do and all. So we're going to see how to find out the question, how to find out the answer of this question very easily. What is given here? The quantum nature, means that is a nature of a light which is made up of the small quantas, or we can say photon. So the quantum nature of light explains the observation on a photoelectric effect. So whatever the photoelectric effect that is performed by the Einstein, that was explained on the basis of the quantum nature of the light. Okay, so what is the main statement that is very closely related to the photoelectric effect? So there is a minimum frequency incident radiation below which no electrons are emitted. That is a threshold frequency that we know. So in the first attempt itself our answer should be this. Now why? Because what happen is that whenever you will going to read the definition of the photoelectric effect or the principle of the photoelectric effect, then it is given there that when the light of having any the when you, so you will going to read that particular statement, then there is a given that the light of having a particular minimum frequency is incident on any material or a surface, then it will eject the electron, or it will conduct the photocurrent, otherwise it will not emit the photons, or we can say electrons from it. So that should be your answer. That is a very basic and proper reading of the statement that is given there in our textbook, that a minimum frequency of the incident radiation is required for the ejection of the electron from the any metal surface. Now there is no need to go for the other options, because other options are also very similar or looking very correct, but they are not directly related with the photoelectric effect. They are the inferences drawn or observation, or they are the characteristics which are given in our syllabus which are related with the photoelectric effect. Means after observing or after getting emission of the electron, we have to conclude, or we have to find out lots of the relations in between the intensity, wavelength, frequency and all and so on. So those relations or those characteristics are given in the following options. So we don't have to go further, we have to just take this first option as a correct option. So that is the correct answer, and that should be the correct answer only. In a lot of the resources, or we can see in the other YouTube channels, or in the other websites also, sometimes they have maybe there is a wrong answer is given, so don't go for it. You have to go on the basics and concepts that answer should be correct. Okay, that is option number A. Last two MCQs are given here. Again we will going to see the four remaining assertion reasoning question, and then we will sum up. Now you can see here what is the question that is given. Magnetic susceptibility of any diamagnetic material is of any diamagnetic material. Basically the magnetic susceptibility is given by the symbol that we know this. Okay, that is equal to intensity upon its magnetization. So basically what is happening here, there used to be the three types of the magnetic material: diamagnetic, that is a paramagnetic, and another is a ferromagnetic. So we should know that in the diamagnetic material the value of magnetic susceptibility is always smaller one, and that is negative 1. That is negative 1. So that is a basic simple concept that we have to keep in mind. Now we know that what happens, sometime we going to get confused with the different values and all, but this is the one thing that you have to mug up, because what happen is that while differentiating the three types of the different materials, you should know these all characteristics very properly, very clearly, and very neatly. So because of that, I am telling you that when diamagnetic material is there, its magnetic susceptibility is very small and it is negative. So what should be your answer? Answer first will be your answer. Now what about the other material? So whenever we see the paramagnetic, in case of the paramagnetic, the magnetic susceptibility is small, but it is positive one, it is positive. And in case of the ferromagnetic material, the magnetic susceptibility is very large, and that is positive also. So basically it should be in the range of the thousands and all. So that should, so because of that our answer should be option number A, that is first, that is small and negative one, that is the magnetic susceptibility of the diamagnetic material. Now next, again next question, that is a 12th question, is very easier one, very direct one. Basically we know that the radius of any orbit, Bohr orbit, is given by Rn equal to r naught multiplied by n square, r naught multiplied by n square. So the relation becomes directly r naught is directly proportional to the n square. So it is a sure shot direct question. Radius of nth orbit of the Bohr model of hydrogen atom varies with n square. So option number C will be the correct answer for this MCQ question. Now we will go for the remaining 4 assertion reasoning question also. So we will going to get the idea how to solve those questions. Again, a very basic and logical concept that has to be used there. So from question number 13 to 16 we have given the 4 assertion reasoning question. We know that I will not going to read this section because you people are very well aware about this all options and all. Even though if in the question paper these 4 options are not given, you can choose very easily, because that much amount of the practice or revision we used to do in our board exams and all. So now see the direct question what is given there. Question number 13, assertion is there: when electron drift in a conductor, it does not mean that all free electrons in a conductor are moving in the same direction. Very correct, because we know that electrons usually move in a very random manner, and because of that, that is called as a Brownian motion, and the velocity which is related to their motion is a drift velocity. So first assertion is correct. Now the drift velocity is superposed over large random velocities of electron. Yes, it is also correct. We know that whenever we individually see the velocity of electron, that individual velocity will be different for each and every electron. Now what happen is that in any conductor, if there are the n number of the electrons are just moving here and there, so we can't able to calculate each velocity of each and every electron. So at that time we have to take a drift velocity, which is a overall velocity. Basically the average velocity becomes 0, that we should know. But for any instance, whatever the velocity that we have to take or consider for any conductor, that has to be the drift velocity. So this drift velocity is a superimposed velocity of all the velocities of the random electrons which are just moving in that particular or drifting in that conductor. So reason is correct, and because of that, what happen, when electrons drift in a conductor, it does not mean it is moving in the only one direction. It can be moving different directions. So that is the correct one. So what should be your answer here? Option number A. Why? Because if both assertion and reasons are correct, and reason R is the correct explanation of assertion A, so we are choosing this option, that is option number A, as a correct answer for this question number 30. Next. Now this is the question which is based on the Young's double slit experiment and the Fraunhofer diffraction pattern. This is again the very straight and direct question, but why I don't know. Lots of the people have given the very wrong answer of this question, and they have wrongly taken the concept of the conservation of the energy. But we are going to see here the very correct answer of that particular question. So what is given here? In interference and the diffraction of light energy reduces in one region and produces the dark fringe, correct, and increases in another region and produces the bright fringe. Yes, so what is happening here, in the assertion it is given that light energy whatever used to be there, and that going to get reduced and produces the dark fringes, and get increase in the another region and produces the bright fringe. Means what is happening here, here is a distribution of the light energy. Means at one point or at one place it is a less, at another place it is a more. Now Reason of this happens because energy is not conserved. Cancel. So from the given wording itself we can say that reason is not correct. Reason is not correct. Why? Because energy is not conserved. What is saying? It is not happening because energy is not conserved in the phenomenon of interference and deflection. Is it correct? No, energy is conserved, but energy, rather than energy is going to get distributed, it is distributed differently. In the dark fringe or at the minima it is less, at the maximum it is more. So obviously total light energy remains same. So reason should not be correct here. So what should be your answer? Our answer should be that assertion is correct, that is A is correct and R is wrong. So I think this is the option number C is there, so that should be your answer. Okay, you may check it in the given option, but keep in mind assertion is correct here and reason is very wrong. So that should be the only correct answer of this question. Now see the 15th question that is given here. The temperature coefficient of resistance is positive for a metal and negative for a p-type semiconductor. Yes, correct. Temperature resistance of metal is positive and negative for p-type semiconductor. I will tell you why. But what is happening here is that the reason that is given, that should be checked properly first. So temperature coefficient of resistance is positive. So you should know the concept behind it. Rather than mugging up this concept or memorizing this concept, you have to understood this very properly. What happened is that whenever there used to be the lots of the electrons or free electrons in the metal which take part in the conduction. So what happens whenever we increase the temperature, what happens when we increase the temperature, they start to move very fastly, and because of their fast motion or the fast random motion, those electrons will going to collide to each other, and because of that there will be the hindrance that is created in between the motion of this electron, and because of this hindrance there is a generation of the more resistance. So what is happening here? There will be the generation of the more resistance, or we can say that there is a motivation for the resistance, and resistance is increases, so it is a positive resistance, so the coefficient of resistance will be positive in case of the metals. Now what happens in the PN type semiconductors or semiconductors? In semiconductors mostly the charge carriers are the holes, and we know that is a negative charges. Okay, so in that case what happens, whenever this hole, or we can say positive, sorry, I have said earlier negative, that is wrong. Okay, so what happens when these holes or positive charges going to get move? So when we increase the temperature, this number of holes will get increased, and because of that the conduction becomes very easier in the PN type semiconductors. So if the current will be more, then obviously there will be the decrease in the resistance. So we can say that there is a negative trend of the resistance in case of the semiconductors. So we can say that the temperature coefficient of the resistance is negative because it is decreases in case of semiconductors while we increase the temperature. So that is the simple assertion and the concept behind the assertion, so it is correct one. Now what about the reason? The charge carriers in the metal are negatively charged particles. Those are the electrons, we know that, whereas majority charge carriers in the PN semiconductors are positively charged particles, or we can say positively charged component, which are also called as a holes. So yes, reason is correct, but what is happening here? Reason is correct, but this reason is not for this assertion. The statement given in the reason is correct, but it is not a correct reason of this above assertion. What is the correct reason for the above assertion is that, what is the above what is the correct explanation or reason? That I have already explained you, that because of the increase in the kinetic energy, those particular particles or electrons will going to collide with each other very fastly, and because of that there will be the generation of the hindrance, and so there will be the increase in the resistance. So but the statement that is given, that is totally different one. So we can say that assertion and reasoning is correct, but the reason is not a correct explanation of the assertion. So option number B should be the answer for this question number 15. Now the 16th question. Electrons are ejected from the surface of zinc when it is radiated by yellow light. Yes, this option is correct, but what is energy associated with the photon of yellow light is more than the work function? No, this is a very direct question that you can find out in your syllabus, that the energy associated with the photon of yellow light is more than the work function is not correct. It is a less. So because of that we can say that here the reason is not correct, assertion is correct. This is the direct question or the basic question that is given here, so we can directly identify the answer of this question as assertion is correct, reason is false. So option number, I think C will be correct one. So in this way we have solved all the 16 question of the 1 mark, where we have seen the 12 MCQ question and the 4 assertion reasoning question, and we have covered each and every question in detail, in depth, and I have also tried to provide the in-depth analysis of the each and every question. I have tried to explain you as much as I can, and because of that you will going to get a greater insight into the each and every type of the question that we have seen here. I hope that this video solution will be helpful for you, because what happened is that I have seen lots of the bigger website or the lots of the institution also going to provide a very wrong answers on the YouTubes also, or on their portals or websites. So what happened, because of that the students going to get misled, and I don't want that particular confusion or the misunderstanding should be there in the students regarding their option, regarding the answers of the question. There should be some clarification or the explanation should be given to each and every question along with their answer. So that is my motive, and because of that I have tried to make it very fair, and I have tried to put much efforts in this particular video solution, so that it will going to help you a lot. And if you find this video solution a very enriching one, and if you like the explanation and all, then you must subscribe this channel and share these videos to your friends also in other communities also. So it will be very grateful for me, and I hope that you will going to see the other videos also which are uploaded on this same channel. I have also uploaded the numerical solution of the same question paper of the physics 12th class. So you must refer those videos and just share those videos. So thank you, we will meet again. So thank you so much.